Now let's look at this gate to the end question. They are saying that we have M0 to M4, 5 mutexes in an array which are binary semaphores, and P0 to P4 and 5 processes. Suppose each process Pi, which means you can take P0, each process Pi means they are talking about each one, executes the following. So what is each process trying to do is, every process is trying to run the weight on M of I, which means they are trying to run a weight on a mutex, right, and then one more weight on one more mutex, right. So every process trying to write down do down operation on two mutexes, and if it is successful, it is going to get into the critical section, and then it is going to release the this mutex. And then it is going to release the mutexes, right. And now they are asking, what could be possible? Is trashing possible, or is the deadlock possible, or is it starvation possible with no deadlock? Anyway, trashing is not a concept here. Trashing, and we can look at trashing in memory management. Don't worry about it now. Now let's focus only on the synchronization part. So now if you look at the code, how it is working is, each process Pi is trying to take a mutex Mi and then Mi plus 1 mod 4. So now let's see how many processes are there and what are the mutexes every process wants. So instead of writing wait and release, I'll just write P and V. That is simple representation, right? So now let's see what happens to P0. P0 is going to wait on Mi and Mi plus 1 mod 4. So which means P0 is going to perform down operation on M1, M0, and then down operation on M1. So P0 wants these two, M0 and M1. And similarly P1 wants to perform down operation on M1 and then down operation on M2. And then P2, it wants to perform down operation on, are you understanding it? Why this? And then down operation on M3, right? Okay, it is going to take like this. See, now P0 is nothing but I and I plus 1 mod 4. It is nothing but 0 and 1. 0 plus 1 mod 4 is 1. And P1 is I, which means 1, and then 1 plus 1 mod 4, which is nothing but 2. And P2 is I, and then 2 plus 1 mod 4, which is nothing but 3, like that, okay. And then P3 is down on M3 and then down on 3 plus 1 mod 4, which is nothing but 0, right. And again P4 is down on M4, right, and then M plus 1 mod 4, which means M1, right. Why? Because 4 plus 1 is 5, and then this, right. So now is any deadlock possible? Obviously deadlock must be possible, right. So you can preempt each process after they execute the first down. So if you preempt P0 after this, P1 after this, P2 after this, P3 after this, and P4 after this, obviously it is going to lead to a deadlock, right. Look at this. See, now P0 has taken 0 and P1 has taken 1 and P2 has taken 2 and P3 has taken 3 and P4 has taken 4, right. After that, watch it. Now P0 is waiting for 1, right, and P1 is waiting for 2, right, and P2 is waiting for 3, and P4 is waiting for 0, right. Wait, P3 is waiting for 0, which means like this, right. Therefore at least here there is a cycle, right, and the cycle is like this. P0 is waiting for P1, isn't it? P0 is waiting for P1 and P1 is waiting for P2, right, and P2 is waiting for P3 and P3 is again waiting for P0. Therefore definitely there is a deadlock possible, right. So fine, deadlock is definitely possible, no doubt in that. So at least in this sequence deadlock is possible. So in the options deadlock is possible. Now what about mutual exclusion? Is the mutual exclusion guaranteed? I don't think so. So if you look at it, there is a chance that two processes might enter the critical section at the same time. Can you just guess what two processes can enter the this at the same time? Watch it. Assume that P naught runs these two lines, then it will directly go into the critical section, right? So it has taken 0 and 1, and therefore P1 cannot enter the critical section, right? But then P2 can enter the critical section because they are both waiting on a different set of mutexes. P0 is waiting for 0 and 1, P2 is waiting for 2 and 3, right? Therefore even P2 can enter the critical section at the same time when P0 is in the critical section, right? And what about others? This one cannot enter the critical section because 3 is already taken. Anyway, you can see that at least 2 are getting into the critical section, right? Therefore mutual exclusion is not guaranteed. What if the question is how many processes can enter the critical section? Maximum number of processes that can be present in the critical section. How many processes do you think can enter the critical section? There are 5 mutexes and 4 processes, and I am guessing that 2 is the maximum number of processes, but you can cross verify it. They didn't ask that, but I'm just trying to do it. They didn't ask this one even. I mean, how many processes is mutual exclusion guaranteed? I'm just trying to do it. No, answer is over with deadlock, right? But now let's just extend it. How many processes can be present in the critical section at maximum? I mean, here mutual exclusion is not guaranteed because 2 processes are definitely present. Now my question is, how many processes do you think will be in the critical section in the worst case? So let's see that. Assume that P0 is already there in the critical section, then what other process can be in the critical section? If P0 is there, P1 cannot be there definitely, isn't it? And P3 cannot be there, and P4 cannot be there. Therefore, if P0 is there in the critical section, only other process which can be present is P2. The reason is, watch it, P1 cannot be there because M1 has already taken by P0, and P3 cannot be there because M0 is already taken, and P4 cannot be there because M1 is already taken, right? Now assume that P1 is in the critical section, and let's see what happens. If P1 is in the critical section, then P0 cannot be there because there is a conflict here, and P2 cannot be there because there is a conflict here, and P3 can be there, right? So P1 and P3 can be there, but then P4 cannot be there because there is a conflict. So if you go on writing like this, I think you'll get only 2, right? Or if you want to extend it, yes, P0 is over, and then P2 is over, P1 is over, P3 is over. Let's see P4. If P4 is in the critical section, let's see what are the other processes it will take. I mean, those are allowed. If P4 is in the critical section, then P0 cannot be there because there is a conflict. P1 cannot be there because there is a conflict. But then P2 can be there, right? So P2 can be there, or even P3 can be there. Watch it. 2 and 3, 3 and 0, right? So either it can take P2 or it can take P3, because once you take P2, it will eliminate P3. Once you take P3, it will eliminate P2. So anyway, these are the pairs which are possible, right? You can check it. So at any time, maximum number of processes that could be present inside the critical section is actually 2. Got it? Anyway, it is not providing mutual exclusion for the critical section. More than one process can be present there. But then the answer is deadlock, that is over there. Fine.